Okay, so we're going to look at a couple examples here of multiple triangles. Now, these are definitely harder, okay? So, because they take more than one step. Sometimes they are going to require some sort of like problem-solving skills, which we know are the hard part of math usually is trying to figure out more difficult problems and to figure out how to get around them. But a lot of them are pretty simple. Okay, it's just more than one step. So this one, I would say, is a fairly basic one. Okay, I skipped a little bit in your slides, so if you're looking for the next slide, it's I don't know what number it is, to be honest, but it's in there somewhere. 39. Okay. So when you have two triangles, what you are generally doing is you're looking for the shared side first. Because if we want to find CD, first of all, I mark it with an X, the thing I'm looking for. Okay, so I mark that with an X. I'm like, okay, I want CD. Now to find CD, I'm going to have to do a first step beforehand. Because if I just try right away to find CD, it's not going to work. If I look at that triangle, BCD, I don't have enough information. All I have on that triangle is that this is 26 degrees and this is 90 degrees. And that's not enough to find a side. You always need two things. You need either two sides or you need an angle at a side. So I don't have enough. So to work this out, what you're always doing pretty much is you're trying to find the shared side. Okay? So first step in these questions is to find the shared side. So here, the shared side, by that, sometimes I think people don't really understand what I mean. I mean the side that's on both triangles. So, right, like if I look at the sides of ABD, there's AB, there's BD, and there's DA. If I look at CBD, there's CB, BD, and DC. One of those is the same. Okay, so the shared side here is BD. Okay, the hypotenuse there. That's the shared side. Okay, is that BD there. So that side, in this case, is the hypotenuse for both triangles. It's not always going to be the hypotenuse for both triangles. I could have it be the hypotenuse for one triangle and the opposite for the other. So you need to really keep it like straight. And what some students need to do, and you might not be one of these students, and if you're not, you do it your way, but for quite a few students, the best thing to do probably is to draw the triangles out separately and work with them one at a time. Okay? It just makes it easier, and I see students get confused less often. So if I just look at ABD, I know that this angle here is 47. Okay, I know that this side down here is 44.2. And what I want to find is that red side. I'm going to name it Y. One thing I would like people to get into the habit of doing is what I see in these questions, and it's not a big deal, but it kind of bothers me a little bit, is people will call both of them X. Like they'll call it X first, and then they'll call the next one X. It's just a little annoying. It's like if you imagine, like if you met somebody and they named both of their kids the same thing. Okay, you'd be like, that's weird. Like, why are they both named Sarah? That's really confusing. Okay, same thing in math. If you put X's everywhere, that's like you're naming it is what you're doing. So if you pick the same name, it's a little strange. So try to pick something different. That's just like a mathematical thing, that getting into the right habit. And I heard someone say here, we're going to have to use sine. So if I use sine 47 equals, and I label my triangle right, so Y is H, the hypotenuse, somebody already said that actually, and 4.2 is the O. So when I'm doing my ratio, which number goes on top?
Opposite over hypotenuse.
So it's 4.2 over Y. Okay, so there we go. So I've got that, my daughter was using my iPad and it's like sticky. Okay, so now we do a division, right? We flip these two, okay, and we do our division on our calculator. Okay, so we go 4.2 divided by sine 47. Okay, sine 47, and I get 5.742. Okay, 43 if you rounded.
Wait, don't round because you're going to use that number.
That's exactly right. So I would definitely not round to 5.7 here. Okay, if you did that, you're probably going to end up getting the final answer a little wrong. Okay, we've talked about this the other day, just about how important it is to not round until your very last answer. Okay, now, if you have a big calculator, there are a few of you in the room who have like the one Tayson has here, Hunter has over there, the like TI-84 ones. They can actually, you can go up and copy your whole number really easily. So if you have one of those calculators and you're wondering about how to do that, just ask me and I'll show you. It's like super easy, and then you can use the entire number. Otherwise, what you should be doing is writing down, if you just have a little dinky calculator, you should write down at least 3 is like the bare minimum. 4 or 5, 6 digits is better, so that you are using most of the number and you're not going to get the answer wrong. Okay? So then we take the next triangle. So then I draw out the other triangle. I draw it out like totally separately. I'm like, okay, so I have B, C, D. And I write out the sides and everything. B, C, D. Woo. And I can fill in my numbers. So I know this is 26. And Y, which I just found, is that 5.7 number. And I want to find X. Now, you'll notice I just put 5.7 there. Even though I just put 5.7 there, when I type it into the calculator, I'm going to type in more digits than that. Okay? I'm just remembering it's that 5.7 number. Okay, so then I figure out what I have to use here. So I label what's X. Adjacent.
That took a long time to say.
Took a long time. We got 26 is down here. So O is here, A is here, H is here. When our triangles are like upside down like this or like wonky, that's when I see people make more mistakes with labeling. Okay, when the triangle gets rotated. So just be careful. Like if the 90 degrees is up here, right across from it is the hypotenuse. I know it's fine, but like it's easy to make mistakes. So I have A and H, so I should be using cosine. So I have cosine. What will I write next to cosine? 26 equals, what will go on top?
X.
And 5.7 on the bottom. So I have to multiply by 5.7 here.
4.3.
You get 4.3?
No, 5.7.
Yeah, 5.743. I'm going to do, so even if I have one of these dinky little calculators, what I would do is like right now the whole digit's up there because I typed it in, right? It says 5.742. I would just right away go times cosine 26. Rather than having to type it out again, then it'll use the whole digit, and I get 5.2 as a final answer. What were you going to ask, Brianna?
So you don't use the full number?
No, you do use the full number.
Oh, okay.
Okay, so you don't need to necessarily write down the whole number, right? There's a difference between what I wrote here and what I type into my calculator, or there can be. Because having to write down all those digits is kind of a pain in the butt, especially if you were doing it really correctly. If you were doing it really correctly, you'd use all the digits. Like you'd use as many as you possibly can. And then and some people write them down, and I don't mind, but it becomes quite messy, right? It's like 5.7432867, and it's like this long thing. You can just write down 5.7, but then on your calculator, make sure you're typing everything, okay? So if you're having problems with that, about the rounding, talk to me about it. I can show you how to use your calculator better. Okay, there's effective ways to use your calculator, and I can help you with it. Okay, so anytime really. Again, I'm here this evening from 7 to 9 in room 229. Yeah. Okay. So the answer here is 5.2. Okay, let's look at this one. This one's actually, everybody try this one. Y first. If I'm trying to find WY, and some of you might not be doing everything I'm doing, that's okay. If you get the right answer, I'm happy. Okay, so if you got 8.4, 20, and you're trying to find that, if I call it X, okay, then I would have to use which of the 3 ratios? So I use sine 20 equals X over 8.4. And I know that's pretty messy there, but hopefully you already have it anyway of your own. Okay, so if I have that there, I just type in, I do 8.4 times sine 20. Okay, and I get my answer. So 8.4 sine 20 is 2.87296, so 2.873. Okay, I think. Is that not what people got?
No.
My calculator's, no, my calculator's in the right mode.
That's what I thought.
Yeah, that should be right. So you might have typed something in funny at the first.
And that's for the shared.
That's for the shared side. And then I have to go on and do the second step. So for my other triangle, that becomes this length, 2.873. This angle is still 22, and I have to find this side. Okay, and again, note that I named it something different. I didn't name it x as well. Okay, and again, now here I have to use which ratio? Not cosine. This would be tangent. So tan of 22 is equal to opposite over adjacent. So that's y over that 2.8 number. Okay, sometimes what I do if I'm writing it down myself, to remind myself that I can't just use 2.8, I'll just put dot, dot, dot to remind myself that number keeps going. Okay, and then so here again it's a multiplication, so it's pretty straightforward. I just times that number 2.8, whatever, times tan 22. And I get 1.2 as a final answer.
We actually did this right.
Good.
Oh my gosh.
Okay. So that is everything, and it's pretty straightforward. Okay. Now I just want to do one more. Now it's actually not in your back to it. Okay. So guys, if I'm going to do one that's not in your slide, so maybe write it down though, because these are the ones I'm going to show you one here that tends to trick people up a little bit more. And you're not going to have very many of these. Like I'm not going to give tons of really hard ones, but there will probably be one pretty tough one on the test. Okay, because that's fair. So if you guys, oh sorry, here. So if we're looking at a tougher one, okay, something that would be pretty tough would be where one triangle, I always find students have trouble with this, is when one triangle is inside the other. Okay, so this causes problems. Okay, when we have a shape more like this, and actually here I'm even going to change this a little bit, try to make it a little bit different. Here, so here I still have two triangles, but remember what you have to be dealing with is two right angle triangles, because I see students kind of trying to do weird stuff in these ones. So my two triangles here, if I name all my sides, if I call this A, B, C, D, E. Okay, so now all these little parts here, okay, I can see that my two triangles are ABE, that's one right angle triangle, and the other one is ACD. So I have two triangles, but one's like inside of another. Okay, and so what you end up being asked is things like this. You'll be given that this angle here is 35. Maybe this angle here is 40. Okay, and then you'll be told something like, here, say we want to find this side here. Sorry, I just want to make it like the one that's here, so I'm going to just take a look at it again. Oh. Oh no, that's good. Okay, so here we go. So here I'm given that from C to B is 7, From A all the way out to D is 12. So be careful with this stuff because sometimes the way the triangles are labeled, students have a little bit of trouble picking out like what the side is supposed to be. Is it supposed to be all the way from A to C? Is it supposed to be just C to B? Okay, so if you're not sure ever about that, if you're like, if you see a number and you're like, I'm not sure what that is supposed to represent in the diagram, ask me. Michaela and Winston, can you stop talking? Okay, so here we have two different triangles. And the best thing, this is when it's, to me, even more important to draw them out separately. Because what I see is students get really confused with the lengths and they start doing really strange stuff. If I draw them out separately, it becomes quite a bit easier here, okay, to do. And actually, if I draw them out separately here, I'll see that it's not so bad. So if I draw out here BAE.
Bay.
Bay.
That means poo.
Hey. BAE, so we have 40 degrees. I have my X, and I don't know the other side. Then if I draw out CAD, if I draw out the big one, and I actually make it bigger, but you know, your drawings don't have to be like super to scale or anything. It's not really, it doesn't matter too much, to be honest, like as long as you know that it's the right thing. And I know that this is 12. Okay, that's what I know. And what I see students do sometimes is they'll put a 7 here from A to C. But that's not correct, right? 7 is just from C to B. That's only like part of it. What I also see students do a lot is there'll be at least one student in the class who's like, oh, X is 7. Yeah, I know it. It's like, X is 7 for sure. Because this looks pretty much the same as that, okay? And they'll just write X equals 7. Please don't do that, because I can't give you any marks. Like, don't ever assume that something's like cut in half, okay? So we don't know what that last side is, that's CA. And so here it's kind of hard, like, which side am I trying to find? Like, what side is going to help me find my answer?
I think you should find the side of C to A.
Yeah, from C to A. That's the one I should try to find. That's right, and then subtract 7. So we'll do the whole thing. So here, the way that you know, if you're struggling with which side do I have to find, it can be hard. It's sort of like something you just get with practice eventually, or if you have pretty good logic, you can kind of see it. But since X is on this side, that's the side I want to find. So if I find C to A, if I name it Y, and find C to A, okay, I would be using tangent. So I have tan 35, and I label my sides, so that's opposite and adjacent. So it's Y over 12, and I multiply on both sides, so I go 12 times tan 35. Yeah, I get 8.4. Y is 8.4. And there's, of course, a bunch of other digits there, and I would use all of them. So 8.402, and it keeps going. So now, I know that that entire side there, all the way from C down to A, is 8.402. This is the part where I see some students have some trouble figuring out what to do. So if I know that this entire thing is 8.402, that piece underneath 7, what does it have to measure? Minus 7, that's right. So all I have to do here is a subtraction. I don't even have to do trig in the second part. It's really just a matter of subtracting. Sometimes you would have to do some trig. They're all different. Okay? Here it would be minus 7. Now the reason for that is because those two pieces together, so here it's 1.4. Okay, so x is 1.4. But it makes sense because these two pieces together have to add up to 8.4. So the answer here would be 1.4. Now you can see, like that diagram, I just drew it, so I just made it up. Obviously it's not to scale, but they're usually not going to be perfectly to scale. So you might see answers that it looks like they're pretty close to equal, but then when you actually find the answer, they're not. So that's another reason why don't just assume that if something looks like close to half, that it is half.